This question is from GATE 2017 Mechanical Engineering paper set 2, question number 36. A single plate clutch has a friction disc with inner and outer radii of 20 mm and 40 mm respectively. The friction lining in the disc is made in such a way that the coefficient of friction mu varies radially, as mu is given as 0.01 R, where R is in millimeters. The clutch needs to transmit a friction torque of 18.85 kN millimeter. As per the uniform pressure theory, the pressure in megapascal on the disc is dash. Let's find out. So we'll start by writing the given things. Inner radius Ri is given as 20 mm. Outer radius R0 is given as 40 mm. Nu is given as a function of the radii. So it is 0.01 times R. Torque T is given to be 18.85 kilonewton millimeter. We need to find out the uniform pressure, sigma. It's in MPa. In order to find out the pressure, as we see that torque is given, we will use the expression for torque. Torque will be a function of the radius and the coefficient of friction, as coefficient of friction itself is a function of R. Therefore, we will write total torque T will be equal to integration from inner surface to the outer surface, that is Ri to Ro, mu times sigma into 2 pi r square dr. This comes from the expression for axial load, because axial load for a small length dr, if we denote it with dw, it is given as pressure sigma into 2 pi r, which is the circumference, into dr, which is nothing but the thickness of the disc that we are considering. So this being the axial load, the torque dt for this small length dr can be then written as dw into r into mu. So now that we have torque, we know mu, we know r, we can find out pressure sigma. So putting everything here, we get T will be equal to, taking the constant out, 2 pi. Sigma is also a constant value, so taking sigma out, substituting mu as 0.01 r. Again taking 0.01, the coefficient of r in mu being a constant, it can be taken out. We have integration, Ri is 20, R0 is 40 into R cube dr. Integrating and then putting the limits, we have 2 pi sigma into 0.01, R raised to 4 by 4 from 20 to 40. Therefore, we can write sigma will be equal to, taking this 4 to the numerator on the other side and putting value of T, we have 18.85. Remember, this unit is kilonewton millimeter. So R we have taken in millimeter. So we'll keep millimeter as it is, but we'll convert kilonewton to newton, so that we get sigma in the direct unit MPa. MPa is equivalent to Newton per millimeter square. Therefore, 18.85 into 10 to the power 3, this will be in Newton millimeter into 4 divided by 2 pi into 0.01 into 40 raised to 4 minus 20 raised to 4. This, when calculated in digital calculator, gives us 0.5 and the unit of sigma is MPa. Let's go back and fill in the answer. The pressure on the disc is 0.5 megapascal. To learn about clutches in detail, you can refer to the NPTEL video Automotive Clutch Part 2. It's from the course Fundamentals of Automotive Systems. The course is by Professor C.S. Shankar Ram. He is from Department of Engineering Design of IIT Madras. I hope the solution will help you clear your doubt. Thank you.